Selamat siang, sudah masuk Bapak Ibu?
Sudah Bu Indah.
Sudah masuk. Aman Bu Indah.
Ya. Good morning, ladies and gentlemen. Today we have guest lecture from Professor Dr. Shakir Ali from University of Muslim University, India. Today he will talk about the role of abstract algebra in information science. Thank you very much for your participation in this event. Before we start the talking of Professor Shakir Ali, I give the time to Dr. Norma Yulia Megawati. Halo, Dr. Norma.
Ya Bu Indah, halo.
To give a speech from department.
Oke. Tes suara saya jelas nggak Bu Indah?
Ya.
Oke. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, allow me in this opportunity to welcome all of the Studium General participants by first praying our grateful and praise to the God for all His blessing, grace, and mercies that have made us possible to gather here in excellent condition and health. Dear Professor Shakir Ali and participant of the Algebra Studium General with topic on role of abstract algebra in information science, Department Matematika UGM is very pleased to host this event. I will say welcome to the UGM, but I know that Prof. Shakir Ali is already a couple of days in here. Okay, to Professor Shakir Ali and participant, thank you for being here. Welcome and enjoy the Studium General. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
I will give back to Bu Indah.
Thank you, Dr. Norma. Now, time to Professor Shakir Ali to share his presentation here. This time is yours.
So, well, ladies and gentlemen, good morning and assalamu alaikum wa rahmatullahi wa barakatuh. So at this outset, I would like to thank to USIIM and especially Faculty of Mathematics and Natural Science, Dean of the Faculty, and member of Indonesia Algebra Society, and in particularly Professor Inda Imla Vijayanti for inviting me and give me a chance to interact the people of Indonesia. So thank you all once more. Today's I'm going to speak a very important part to discuss from last 5 days in the same Studium conference, and there are a lot of discussions on the applications of mathematics. So I decide, and after discussion of several faculty members, how to describe algebra, the role of algebra in the present scenario. So I select the topic, the role of abstract algebra in information science. By the way, I'm sorry if well, so I am sorry for because there is some gap in the flyer, and that by mention the role of abstract information science. So in fact, this is the, in very short, we have decided and modified. So both means we not read it just in around after 11, I found the the flyer, then I pointed out Professor Anda, but it was too late. So for this, I'm sorry from my side, it's not from the others. So the topic is the role of abstract algebra in information science. So let me give you the brief about the people, because we have many good discussions here. And Alhamdulillah, we have signed just MOU between Aligarh Muslim University, Aligarh and UGM. So let me give you just brief introduction about EMU. So if you have chance, visit, so you know about the how to reach and where you have to go. So this is the EMU at glance. We pick up some famous part of EMU. This Maulana Azad Library, Sir Syed House, Victoria Gate. Not go in much more detail because for a few days we have already given something about this EMU at glance. But anyhow, the first row, that is the Victoria Gate, from where this university was started in the year of 1857, around that. And the name of the madrasa was Muhammad Ongdo Oriental College, and it was become the full university in the year of 1920. And then we have a lot of faculties, around almost 15 faculties: Faculty of Arts, Faculty of Science, Faculty of Medicine, Faculty of Unani Medicine, Faculty of Law, Faculty of Business Administration, means so on and so forth. And then in the last row we have because the EMU is spread around more than 9 kilometers, 8 to 9 kilometers. So we have the several gate, and pick up one of the gate recently established by the Prime Minister of India, Narendra Modi, that is called Century Gate. And then the right part of the last corner, this medical college, it is in fact is the full medical college, means we have studied the medical sciences, almost all branches of the medical sciences, and also we have the hospital and so on. And then come on, Department of Mathematics. So it is one of the oldest department in India, because it was established very parallel to during the period of British, so when the university has started. And I'm glad to share you with about our department. It is ranked around 96. Sometimes 100, sometimes 110 from last 10 years. And we have at least 3 faculty members in the list of 2% scientists according to the Web of Science. So this is really a matter of great pleasure for all of us. And being, I know this Muslim, so really very proud. So this is the area view, just this center part. Then if you move from left to right, because we have a women's college, we have separate girls' hostels, girls' hall. Girls means women's college, means undergraduate study is the the separated from both female and male, and from the graduation or post-PhD, then we have the co-education. So if you look on the map, the red type building from right hand side is part of the women's side. And if you look on the center green part, then the building again. So this building is almost here. We have mathematics. Can we use the pointer? Yeah. So, and then this is the map of India. I'm sorry to ask you, I'm audible to all of you, those who are from online especially.
Yes, some.
Online, means I'm audible to all of you.
Yes, very clear.
Oh, good. So look at this map, and so yeah. Okay. I will see. Okay. Anyway, it's not problem. So we will use. So if you look on the map, and near Delhi, this is Delhi, and this is Uttar Pradesh. This is the state where the AMU is, and between Delhi and Uttar Pradesh here is Aligarh. So it's not far away from Delhi. It is around 3 hours or something from by car. We have well connected flights, means trains also. And then this is AMU Algebra group. So we have almost 7 or 8 faculty members. Some of them just retired this year. So right now we are only 6, led by Professor Ashraf, working in pure as well as abstract algebra. Cryptography, coding theory, graph theory, and image processing. So these are the area apart from the general abstract algebra. And then this is the research collaborations across the world. I mentioned because you should know, maybe we have time to discuss how to make collaborations to the other countries in the proper way, means how to get the financial support, because it's not easy to make all these things. So the way we should know how to collaborate and how to make. So Alhamdulillah, we have make the exchange program with several universities. The first program we have dealt with the University of Slovenia in the year from 10 to 13. And then another program we finished, this is Busan National University, South Korea, that was also has finished. And then the third program run by our department with the exchange program with Taiwan National University, Lee, and it's one of the, because these two programs, University of Slovenia and Taiwan, they are based in the core area of derivations. So we start the study of derivations from University of Maribor in the collaboration of Professor Matthew Bracer and Joseph Buckman, the founder of functional analysis, in other words, you can say. And then we have another program recently from 19 to 22, finished with Karaman Mehmet University, Turkey. And like this, we have some other collaborations to Morocco as well. Anyway, now it is time to have collaboration with Indonesia. So Alhamdulillah, we will have AMIO. So we will look forward how we can collaborate and how we can help with each other. Inshallah, we will go in the positive direction. So this, as we mentioned in the title of talk, role of abstract algebra in information science. So, dear academic friends, we are now in the era of information science. So definitely, as an algebraist, we should know the role of algebra. So today we will discuss. I will discuss on some part, not because there are a lot of beautiful things in algebra, but we cannot do all in 1 and 2 hour lecture. So we will fix on the key topic of my research, that is ring theory. Okay, so we will start the role of ring theory in the information science, computer science, and like coding theory, cryptography, image processing. So just we are dealing with very one of the most important wonders from abstract algebra in terms of rings. Okay, and we call it this ring Zn, the ring of integer modulo n. Now, so our focus on this ring, and the importance of this ring. So particularly if we are talking about the structure of this ring and what is the role of this ring in information science. So just take, if you for n is equal to 2, and then you will get the ring Z2 and 0, 1 addition modulo 2. I hope all of very familiar, but this ring is not new and it is very famous. And this ring has different nomenclature in the mathematical sciences. Like people who are working in the computer algebra, they call algebra for information science. People working in engineering, like electronics engineering, call Boolean algebra. Means such algebra, they are Boolean algebra. And some people call algebra for information science, computer science, so on and so forth. So it has a different name. And also this is what the ring, or this is what the one of the important algebraic structure which change the shape of the world. Are you agree? I'm talking. This lecture is not, the very technical. So please we share. If you have any, maybe you can share the discussions. My first the point is this structure, small structure, change the shape of the world. So how many agree from this statement? Or anyone of you do not agree? I'm saying this small structure, algebraic structure, change the whole world. Make it doesn't make the distance does not matter. Like for example, many of my students I am in Indonesia, and now they are listening my talk from India, some from Turkey, some from Malaysia. And do we think how it is possible? Because of such nice structure. Okay, this is one of the example I just quote the role. Discuss later on in detail, but this is the simple example we are talking. Okay, so today's talk is based how we will construct such type beautiful things. Okay, so let us move. So this is about the sketch of talk. Just give the motivation for this in particular sector in the present scenario like information science. So then we make the fundamental, use the fundamental mathematics, how we can construct such beautiful things. And then the last part we will discuss space strategy applications, where the applications, okay? And finally, give you a recent work in coding theory, cryptography, in the light of ring theory. Okay, so this is what, and then let us move. So the first part, those who are aware about the coding theory part, this is the paper. This is J4 linearity, which make algebra more and more interesting. Because since 1994, this Kumar and one of my co-author, Patrick Soul, they are in fact, this is path-breaking paper which shifted algebra from field to rings. Before, all are concerned with fields, cores over fields. Okay, like if you look on the Z2 in fact a field. Okay, but this is what the smallest field, and since the whole information science has started from this point, so that's the point of concern. What happens where you don't have a field? Means we have an arbitrary ring, how we talk about arbitrary ring. So this is the paper which make the coding theory more interesting. That means all people who is working in the coding theory from the security point of view, they shifted to ring theory. Okay. Now in test of people from those who are working the pure of algebra, shifted to the abstract algebra. So nowadays, we can't say algebra is pure or applied. Okay, it's like interdisciplinary area has application independent. Then the second paper is recent one on cryptography. So basically, we will come later on. What is the role of rings in the cryptography? So this is the one of example. Look at the unsubfluent trigonometry MDS matrix. In fact, MDS matrix are those matrices which all some matrices are non-zero. Okay. So why this paper I quoted? Because all the entries of this matrix are taken from rings. Okay. So this is the entry of rings in cryptography. Then if you look on third paper, that is image processing, the application of ring theory in the segmentation of digital images. In that paper, they also consider rings via some matrices. So all these three papers based on the ring of integer modulo n. Okay. And then let me give you the key mathematical tools and the construction, how we will get and how the basic mathematics play an important role in construction of such beautiful things. So these concepts are not, the new one. They are, many of us are familiar because we already studied these concepts very undergraduate level, sometimes before, like, equivalence relations. Okay. So what is equivalence relation and how the equivalence relation play an important role to construct this beautiful ring. So this is what we call the equivalence relation. Let us be non-empty say the relation. This on S is said to be reflexive and symmetric transitive. So if S is non-empty set and together with this operation, then we call the relation is equivalence, and this equivalence relation help us to construct the equivalence classes and then move one by one. And then you have this definition of the equivalence class. So let S be non-empty set and relation is an equivalence on S. The subset containing A is the set of element B such that A is equivalence to B. And then we construct all the equivalence classes. And the equivalence classes collect all the equivalence classes, we construct a structure. Okay. So just for example, this is the example where we have an empty set and then we relation and then we find out the equivalence classes. So because this is the set a ring of integer modulo n, it is concerned with basic structure of ring theory. Okay. So how we deal with this ring? So we make define the equivalence classes and on the ring of integer. That means a set of integers, and then we construct this ring. So let n be a positive integer, then we define the relation on C as two integers x and y are said to be congruent modulo n if and only if x minus y is divisible by n. That means if x minus y is equal to k times n, where k is again integer. So of course, if we have this relation, then this satisfies all three property of equivalence relation, and then we construct equivalence classes. So this example, in fact, shows for those who are not very much familiar. So this is the very clear the information I found one by one equivalence classes. Okay, and then we collect all these equivalence classes. So, and then next example is, okay, so we collect all these equivalence classes, okay, and see the behavior of this set, how this look like, okay. So for example, if you have, this is definitely from set of integers in finite set, we construct a finite set, okay, and this finite set is means you can construct group, ring, field, even according to your need. If you need group, yes, you can do. If you find need particular type of ring, you can fix this n and you can generate ring. And of course, if you fix this n as a prime, then it becomes a field. So this is very, 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 very famous and very, very important example in abstract algebra. People not understand this importance, like those who are not in mathematics, in fact, not in algebra, they are very curious to know what is this everywhere in like information, computer science and information science, coding theory. They are very curious to know why this structure is so important. We can deal with this because we as an algebraic, we are not giving its value, but it's very, very important in the context of the present time. Okay, so move fast because we will going to construct ring with the help of these mathematical tools. So again, we have some definition, let n be a fixed integer. And of course, if we are integers, then a is congruent to b modulo m if m divides b minus a. So if you look at this definition, then a congruent to b mod n. So we can generate this in term of equation. How to write in term of equation? So you look at the property in next result, second one, okay, that you write down a is equal to b plus k times I. See this one, okay? So means you can just transfer the things and then come on what we call ring. I suppose to not define, but because we are talking about the role of observer, so we will just go precisely what is ring and what is the field. So this is what an empty set satisfy 1 to 4 conditions. So if you look at this, becomes additive ability. So in short, we can say R under addition is a group, R under multiplication is semi group, and both distributively are satisfied. Then we call this as a ring as whole, but we write in all the properties to make this difference between sometimes the group, ring, and field. So if you look on the first fifth property, these are property of the additive group. Then the seventh one is semi-group, and the eighth property is distributive law. Okay, and these are the very famous and classical examples: the set of integers, and the usual addition and multiplication, the set of rational numbers, and of course, these are the set infinite orders. Okay, infinite ring. So the natural question how to make the in case of finite. So if you deal the finite case, then this is the best example that we have mentioned here. And another very famous and powerful example of non-commutative rings in terms of 2 by 2 matrices, and as this ring will be very important in cryptography when we taking the elements of matrix from the ring, and then we take the algorithm. Yeah. Now look at the next definition. This is the definition of field. Okay. So that means it's a ring when becomes a field. That means if non-zero, we collect non-zero elements. If non-zero elements form a group under multiplications, then definitely it will form a field. So it is very interesting nomenclature the field. Why field? Group, ring, field. Okay. So this field has some connection, the natural field. What we're talking where you have rice field or vegetable field. So do anyone think how it relates this name to this field? I mean, students, those who are in research, if they are going some practical life, if somebody asks why field is called field. Yes, anyone? I think, guys, those who know, if you are at home, your parents, suppose they are not, they ask, what this field? Why are you talking about the field? So how you justify in that sense to satisfy you? I pointed out it had very close connection with the field, natural field, rice field, vegetable fields.
The operation and the rice field.
That's question of interesting.
Yeah.
Okay, so Professor Srivahini also pointed out what the operations. So if we're talking about the mathematical, okay, and we have the 4 fundamental operations. We everybody know. Talk about group is 1, ring is 2, and field. Yeah, I'm seeing that. So these are the operations. 4. All fundamental operations. All possible fundamental operations holds in field, like addition. Then come to subtraction. So subtraction you can generate by addition.
Oh, so you input the subtraction, yeah?
Minus. Then you have multiplication. A left division. Division we always write. That is A into 1 upon B. So that's why in field we have all 4 fundamental operations. Now come on the other side of field, how we make connection with this. So what is in fact field? Field is the place, Professor Srivahini, Professor. I am yeah. So there are when we are talking about the field and how to make connection with this the natural fields. Field is the place where you can perform, you can run, you can jump, you lay down, or whatever want you can do in the field. Okay, all possible things but one. In terms of mathematics, the field is the structure where all possible operations can perform.
Question.
Okay, so yeah.
Question. In Germany, field is Körper. Körper means body.
Field?
In Germany,
Huh?
field is German is Körper, means body.
Maybe they have different nomenclature. I'm not sure about this terminology, but we connect field to that natural field where you can do all possible things. Okay, so why this makes too interesting? When you told this story to the students, they will enjoy all these what fundamental operations are and where they perform, which are structures where all possible things can be done. Means we can add, we can subtract, we can divide. These are 4 possible ways of doing the mathematics. So that's why we call field make connection with the natural fields. Okay. So do you have any question? No, I think
my question is relating with the operation.
Yeah.
About subtraction is actually from the addition entity. So why you say 4?
Because basically there are 4 fundamental operations. So how to generate the 4 fundamental operations from 2? 2 is common. Addition and multiplication, these 4 are, then the rest you can generate with the help of. That's why we are talking about. So this is this means we can't find the all things in the literature sometimes to give the students 5 field to so-called field. Okay, so to motivate them, we must have some connection. If we connect the mathematics to the real, the real life problems or the real life, really it becomes very interesting. For example, if somebody asks, what is the role of mathematics nowadays, real life? So how to give answer in very short? Because so you give just yes, you have everyone has a mobile family. Even people are not in literature, but they're using the mobile and they're doing the net banking. This is what the mathematics. This is what the abstract algebra. Because they put first their password, then would get OTP, then make again process. So together all these things, if you give such type of tell to such type of motivations, they understand the role of mathematics in short, in general. And then so these are not go, and then come on the main component of algebra means ring theory, how to construct. So what we did till now, just to make the base to construct the ring of integer modulo n. Because this is the structure and for which we have concern and its importance. So with the help of, as I told you, we have a relation on that side, then we construct equivalent classes, and then we define, means in order to make Zn as a ring, we define our addition and we define multiplication. So we define addition and multiplication with the help of in terms of congruence modulo and relation. So if you look on this one, the definition I have just mentioned here, because we have R, with subtraction, then multiplication. So these all things are available for congruence, modulo, and relations. They are well defined in that terms. So with the help of congruence, modulo, and we define addition in such way, A and B are the conjugate classes in Z, and then we define A bar plus B bar is equal to A plus B the whole bar. Okay, similarly define the multiplication, and then we look the properties. Is this Zn with addition modulo n form a ring or not? Okay, and this is what we call addition modulo 2. So then we check, of course, this form a ring, and this is a finite commutative ring with identity. And this ring, in fact, if you look on some more important property, then this ring has because before the people are not talking about the ring in terms of information science, we are not thinking why this is so important. When from last few years, it becomes very, very interesting to look the behavior of the element inside the ring. Suppose we have a ring of order 6, okay, or 4. So how this look like? Properties of element each. So look, just come on the main issue. Let's give you this result because we're going to classify the residual class A in Z in invertible if GCD of A and N is 1. That means they have the count factor. GCD is 1. And residual class ring Zn is a field if N is prime. So this part, and then we collect all invertible element as you saw. This is also from a smart list structure that is a group in terms of group, ring, field, and vector space. Okay. So these are the few examples I just coded for core. Look at this one as we discussed. Like we have N is equal to 2. And then it form of course group. If you consider the first table, that means addition, and you combine this addition with the multiplication table, then definitely it will form a field. Okay, so you check all because it has only just 2 elements, and that's why it is called the smallest field. Smallest field, and it has its own name, that is Galva field of order 2 in the literature. Okay, and this is the field as we talk, it is the algebra for information science. Consider algebra for information science. So we look the behavior of these elements, how many such rings have idempotent, have inverse element, and then have idempotent. So the idempotent and sometimes unit elements is really, really very important when we talking about cryptography. So because the matrix we consider over the ring, so these elements come from the unit elements. So this is what is make more important, more interesting to the behavior of these elements. So this is then similarly you have IN3. This is also as we remarked this, if N is prime, then it becomes a field. However, if you have non-prime numbers, so this is the ring, and it also has very, very important observation in terms of its element, because this Z4 has scored the first paper in 1984, because the people who's working in the coding theory, they always think about ZP, but not think about when P is not prime. So this is the first landmark paper by consider Z4, okay? And this paper then opened the whole area, interest for the pure algebra is to shift in applied algebra like coding theory. So that's why, and also see, I told you unit elements, inverse element, and the other element, idempotent element. I shall talk about this. So the observation is very important if you go inside of these rings. Okay, so in order to make our next results are more important, that means we have another notation we call Euler-5 functions, because the order sometimes very of a group are mainly in cryptography denoted by this 5 functions. So 5 function is a function from a natural number to natural number with this property which phi m is equal to a, where a belongs to 1 to n minus 1, and with the condition GCD of a n is 1. Then of course the order of Zn star means non-zero elements we are talking is phi n. View this. Okay. So we are going to shift in the coding theory part. We decompose this Zn in finite rings, means we construct a new ring with the help of R1, R2, R, with the help of these rings. So we decompose, and then there is very famous a tool from number theory that is called Chinese remainder theorem. Okay, so means with the help of Chinese remainder theorem, we construct a new ring, and that is defined here. Let R1, R2 be rings, and their product is denoted by Ri, the set of all n tuples with component wise addition and multiplication. Okay, so this is again in testing ring, and then we apply this Chinese remainder theorem and construct a field which of order like 8, order 4, order 16. Okay, so this makes sense. So this gives the another decomposition. Let n1, n2, and nn be the pairwise co-primes, and n be factorized like this. Then the map f Zn to this defined by f is equal to a mod n1 comma dot dot a mod nk is an isomorphic ring. And then look at the example how we decompose Z6 into fields. How we write ring in terms of field. So this make more interesting. Okay, and then Galois, we talking about the Galois field, in fact, and Galois field means the finite field. Okay, so Galois field, concepts many ways. You have a polynomial, means a irreducible polynomial, then you can construct Galois field with a finite field. That means that is n, where n is prime. So for p is equal to 2, p is equal to 3, p is equal to 5, so on and so forth. But they are the well-known structure. But how to construct the new type of Galois field with the help of polynomial rings? Sorry, polynomial that are irreducible polynomials. Okay, so this is the another construction just mentioned, because we use in coding theory the finite how to construct a field from given polynomial. So look at this, the set of all means the polynomial of this form, then set of all polynomials over R with indeterminate x is denoted by Rx, and of course this is ring. So let p be a prime number and n be a positive integer. Then there exists a finite field which contains exactly p to the power n elements. So, and this is the way of the construction of finite means Galois ring. Sorry, Galois field. So let g f p to the power n for any prime p an integer greater than 1. So g f stands for Galois field, and p is called the characteristic of this Galois field. Then g f p is called prime field. Okay, and this is also another interesting thing. Let px be an irreducible polynomial of degree n in zpx, then gpf to the power means how to generate the finite field with the help of this polynomial. So this is the way of construction we have just discussed here. So then we get new type of Galois fields. So this is the precisely example how to construct a Galois field from a given polynomial, that is irreducible polynomial. So look at here, we are going to construct a Galois field of order 4, because that does not exist a field of order 4 in general sense. Okay. So how to construct the Galois field of order 4? So this is what we have taken. Look at the idea. We have a irreducible polynomial, that is f(x) is equal to x squared plus x plus 1, and then we have defined like this. And this then we find out these elements, see the multiplicative table, addition table, where alpha is the primitive root of this polynomial. So with the help of this alpha, then we consider again two operation, addition and multiplication. So then this field of order 2 we are talking, that is GF2 has means this we call it GF2 to the power 2. So it has the field of order we have 0, 1, alpha, sorry, and then we have alpha 1 plus alpha. Okay, so when alpha is this one, so this is the way of construction, and this construction is very important in the field theory because we need a course over such nice rings. Okay, so then we move on.
Questions before we can in mathematics, the proof given any positive integer n, the existence of there exists a polynomial, irreducible polynomial of degree n is hard to study in the literature. Can you show where's the literature that describe the proof in easy way?
No, what your question means in terms to decide about the reducible polynomial or decide about the field?
Yes. Given any positive integer n, is there the existence of irreducible polynomial of degree n for any n?
How to decide?
How to prove?
There are several, the procedure in the literature how to decide of a polynomial of degree n to be reducible or irreducible. Like the simplest and very common, which I think you study in graduate classes, that is the Einstein criteria, one of them. Okay, you can check with that. They're well-known, well-defined criteria to check the eligibility of polynomial. Okay, like for example, Lanjar criteria is one of them. Then you can we have another one. One by one we can state.
Okay, thank you.
It's very common in abstract algebra. You any book you find criteria, eligibility criteria. You can find several criteria. Is okay. It's a very simple one. Any other point?
When I have the books, the proof is so long. Can you simplify?
What we can do, sometimes if you need short proof, then you follow another rule. Okay, maybe sometimes what you have the Einstein criteria, maybe sometimes is failed. Then definitely you have another method to check it. But there are several methods in the literature by which you can check the eligibility of polynomial. For example, if you have polynomial of degree 1, what you can say? Linear polynomial, how it is reducible or irreducible? Simple question. There is no need to any criteria, just think. Yes? Polynomial of degree 1 is irreducible or irreducible? Simple. Then go on polynomial of degree 2. That you need, you need to factorize.
Yeah.
Okay. Similarly, you can increase the polynomial of degree 3, you need to factorization. Sometimes the factorization is not possible, then you search another tool. For example, in case of polynomial of degree 3 greater than 3, you check by Einstein criteria. Okay? And sometimes what happens when Einstein criteria fail, then you have mod p-test. Now I'm with you more detail if you're interested. Mod p-test. Okay? And then in similar way, you have and there are similar different criteria to check. Okay? Yeah. Well, then we are going to towards from constant from Galois field towards Galois ring. Because Galois ring has another very interest in coding theory. So Galois ring, let us just be, I have just mentioned some definition example how to construct Galois ring. So Galois ring is defined to be a finite ring, okay, with identity such that the set of zeros with zero added form a principal ideal generated by this P for some prime number P, any 1 into P, so generated by P. The main classical approach to study the Galois ring, which will be noted by G P to the power n R, where R is prime number and n are positive integer. Look at the example by which you can clear what is the Galois ring. Last one. If n is 1, we consider Galois extension now. So Galois ring, in fact, need some more things like Galois extension, field extension, and automorphism. So with the help of all these components, we form a Galois ring. So when n is 1, we consider the Galois extension of degree R of field Zp, where Zp, the isomorphic to Fp, the field of order P. Then the Galois ring is written, you can find Galois ring with the help of this idea that is GPR is nothing but G P to the power R, that means Galois field of order P to the power R, of characteristic P. This is another example, but really we did not go into such more examples. Okay. And then we are moving toward the coding theory part, how this coding theory intensive for the ring theorist. So let us go on for the homomorphism, the very, very important concept in the ring of homomorphisms. So define a ring of homomorphism from mu plus Zp to Zp, okay, extended the ring of homomorphisms and let fx be a monic polynomial, irreducible polynomial, then this in Zp of degree R in Z to the power P x. So this is the what we are looking towards the construction. Then you have residual class ring Zpx upon the polynomial generated by fx, where fx is the irreducible polynomials, and then you construct such a ring, and that has a structure of Zp to the power x upon x. Okay, I mean the polynomial ring over a field means a field of characteristic P. So this type of structure we are interested in field theory, and these are the people who working before towards moving on ring theory part. They in general, like in period in 1984, the system of digital transmission of information already exists, such as telegraph, where the Moore code in 1830s is used. And then similarly, and then other they move in like Hamming distance by Bell Labs, means they use all these things even in IT as well. 1 and 2, so what we are talking and before. So ring theory has been next step, means nowadays becomes the area for the research, like linear code over rings of characteristic. The rings are factorized because the underlying alphabet has a structure of finite rings. So this is work. I just moved to few more ideas about this toward the cyclic codes over finite rings. So this is work started in 1972 in the setting of fields, but it will be transferred to ring in the year 1994 by Hamas and et al. In the paper by like Z4 linear code. That is Z4 linear codes. This is the coding theory totally based on ring theory. The first paper deals with that. This is in the footnote, last one I mentioned. I think first paper we have mentioned in the discussion of motivation. So this one. And now we move on this few terminology to in coding theory. So a code of length n over Gm, Gm is a finite ring of order m, to be linear if it is a Z submodule of Gm to the power n. Okay, then you look at the examples, and these examples are, of course, sometimes taken all taken on finite rings. Like C has this form, and then what does the C look like? So C, of course, the submodule of, look at the Z submodule of Z4 2 over Z4, a linear code of length 2 over the ring of Z4, and so this is the in communication system implying to the quadratic phase shift key the preferred assignment to information bit to the 4 possible phases. That means using some tool, one of the tool is called gray map. So they transform, what is role of gray map? Gray map is map that is the from field to convert to ring. In fact, so with the help of gray map, we transform from a field to rings. So there is little bit just I make how to transfer from to ring to the field. So it make more intensive. So the gray map usually denoted by 5, and this is Z5 from Z4, that means the ring, okay, and to Z2, that is field. So then they see the behavior. The examples we have taken, like 0 goes to 0, 0, 1 goes to 0, 1, and then 2 goes to 1, 1, and 3 goes to 1. So of course, this map is bijective map from Z4 to Z2. Okay, so with the help of these map, and this map we call gray map, we transform from ring to field. This is the key tool means we consider ring, and how we transform these rings to field. So make the sense. And then this is have one by something called the Hamming distance and Hamming code. So there are so many things we will use in the coding theory, but I think we will not go in much detail in coding theory part. So let us see this the Hamming code of length. As I told you, initially the matrix ring play a very important role when we need some examples, either in the counterpart or in seed part. So this is what here we using the C means code of length, Hamming code of length 7 with parity check matrix. Okay. I think we'll leave this part, then we move to another part. So much. So these are some examples of the ring theory based coding theory. So first is the Reed-Solomon course over ZQ. Means this is what, with the help of the matrix, we constructed this the new codes. The Reed-Solomon codes are very famous in the coding theory because it has a lot of information in science of communication. Like chips, you have these small chips, and these chips has used this type of coding. So, but it's very complicated. Sometimes you go on the whole process. But how all these entries are from the ring constructed. So I leave this. Many of us, because as a mathematician, not as a mathematician, but as a human, we know the DNA role of DNA. Everyone we know is very important at a medical point of view. Okay, so see how the algebra not in the coding theory is go to the medical science. Okay. So the codes that is called DNA codes play very important in the DNA human being and then DNA computing. Okay, that means in supercomputing. So the codes they choose that is the ring we are talking Z4. So Z4 ring provides the mapping of DNA sequence onto elements of 0, 1, 2, 4. So there are a lot of things from the ring theory people take in either in the medical science or in information science. So DNA coding play both sides. If you're talking information science, that's the DNA computing. If you're talking about the medical science, then the DNA only. Okay? Genetic side. So both play a very important role. It means ring theory is play an important role in both the part. It means the human being and in the computer side. So the ring Z4 serve as a valuable tool in DNA coding and enable to compact the representation and error correcting in DNA sequences. Okay, so this is the ring. One of the examples, there are several such examples where such type of structure are considered as application. This is one where two places I told you. Means if we are talking about DNA in medical and other DNA computing, that means supercomputing. Both places this Z4 play a very, very significant role. If somebody is more interested to find more details, then I mentioned the paper in the footnote. This find the more information about this particular type of ring. In fact, this is also the particular type means big. As I told you, there is a way of construction of a new ring from the old rings. Several ways you can construct. So if you look on this ring Z4 and plus WZ4, this is another ring. Okay, we construct with the help of Z4. So it's depend on your requirement and timing, what things you need at what time. So this type ring, there are several times, like if you change this ring, Z4, then WZ4 plus W square Z4, and so on and so forth. Or if you need to more detail, you take different WZ4 plus TWZ4, then you can pick up two elements and construct another ring. So this behave different from differently. So as time to time, I pointed out some places, give the example to explain the things. Please be careful. If you have any doubts somewhere, then raise your hand. Now we are moving from coding theory toward the cryptography part. So not going much more detail. We are interested only what tools we will use in the coding theory cryptography. So now we are talking about the first tool. Square matrix A is an ambiguous matrix. First, we just brief what is the ambiguous matrix, so you understand the meaning. So ambiguous matrix is whose every square sum matrix is non-singular. This is the definition of ambiguous matrix. For example, if you look on Z5, we constructed some ambiguous matrices like then A is of this form 1, 1, 2, 1, 2. Of course, both are non-singular. Now, to become a non-singular, these matrices, in general, then we will check these sum matrices. If all sum matrices are non-singular, then A and B we call ambiguous matrix. Okay? So, you know how many sum matrix has, we calculate, but because take very simple one, so easy to find out the sum matrix of A, and this of course A is non-singular, all its sum matrix are non-singular. So A and B are non-singular matrix of order 2. Can you play what are the sum matrix? How many sum matrix of this type of matrix? Yeah. Do you have any idea? Because if your matrix of the order bigger, you have problem, because this is very small matrix, so I think it does not have problem.
Without zero.
Without zero, yes, this is already.
The matrix without zero component will be MPX because of the only non for the 2 by 2. For the 2 by 2.
Yeah. For 2 by 2 means.
For 2 by 2 is easy, yeah.
Like this is look like, but not always. If you just remove this 2, Again, you write down 1, so it becomes, singular. So it's not necessary. But the question is, the entries choose very carefully. Okay, in such way, but all some matrices are non-singular. And then the matrix is emptiness. So these are simple examples. However, if you need bigger matrix, then it is not easy to start. You need computer. Okay.
So I have a question.
Yeah.
The name MDS, it is have a correlation with. Is it have a correlation with MDS code, maximum distance variable?
Yeah.
And the next question is, submatrices means proper, or we can only think as improper subset. That is
be proper and be improper and improper. But total, we are talking total sum matrices. Okay, total sum matrices. So first is take A itself. Okay, so of course it's non-singular. Then go for subpart. Subpart just actually of order 1. If you have 4, so of course of order 1, 4 means the non-singular. And what is left, bigger one, 1. So now total is 5. 5 is non-singular, and hence is MDS. But of this order, if you go for order 5, we cannot go like that way. That means we need some procedure, and that procedure is handled by computer, some program. So we always use some tools in coding theory and cartograph to check all these entries or the validity of the matrices. And then we take another, so this is check, but it's not easy to check because it's of greater than 3. So but anyhow, there are interesting facts about this. This data is already given. Then, if A is MDS matrix, NY matrix over finite commutative ring R, and U R. Remember in the beginning, I told you, the integral part of finite ring, the observation amongst the elements is very, very important. It is not very much interested for the pure algebra people, but now it becomes much more interesting because of the information science. Why? They make surgery of this, like small structure of order 6, ring have order 6. Then what they make, check everything. Like unit elements, how much unit elements of Z6, how much the idempotent, how much element has the shade filbers. Okay, like this, and this characteristic makes the ring more interesting. For example, if you have such entries, we are talking about entries, then look at here, AB MDS matrix of order n over finite commutative ring R, and UR denote the set of all unit elements in R. Okay, with the condition the order of the unit elements is less than or equal to n. So this set of unit elements play a very, very significant role when we consider matrix, in particular MDS matrix over ring. Okay, so ring means you have a ring, but elements are units. So the recently we on working means we shift in the cryptography part towards the ring theory by considering such idea. Okay, so this is the example I just quoted of field of order 8. Okay, so we construct this subtype. Hello. Yes. Any question, please?
I think it's by accident.
Okay. So this is what I give you idea, okay, about this type of ring, that is Galois ring, construction of Galois ring, and then we construct a matrix with the help of primitive roots of that Galois ring, and then we get a matrix, and this matrix work as MDS matrix. So the MDS matrix commonly used in the construction of blood cipher. So what I'm moving toward the security part. Okay. block cipher. They are part of the security. So block cipher, which type the semantic encryption algorithm that operate on fixed length blocks of data. In particular, MDS matrices are often used to construct a substitute box in the block cipher, are used to perform one-to-one substitution block plain text into balanced cipher text. Means we are talking about the cryptography. How we send, the secret message, okay, to another person, and so no one can read it and no one can make any modification. So this is integral part of the security, and that is a very, very important, and how to preserve, how to make it more and more strong. So nobody can destroy. Like, for example, very simple example I am just quoting. Nowadays, when consider the net banking, we send, put our password, we receive the OTP, okay, and then the process is started. And the OTP is, is very important because it provides the information, the person who are that person which is using this card, okay, and that requires all the information because the system does not see your faces. No, it just based on the coding. Coding is your mobile number, your date of birth, your another ID number. Okay, so these ID number already feed when you make your account or make your system. So this type of when we're talking about this, and then the inside part that the OTP play a very, very important role. And if this is sometimes wrong, then you cannot do the problem. Fraudulent, they cannot move ahead because then another ask a question. Like what is your date of birth? What is your mobile number? If the fraudulent, then of course he did not know. But if it's actual, then they ask your date of birth, you put what this, then they further process. So there are several steps of checking all these things. So in the advanced encryption system, the MDS matrices are used mixed column operation, which is one of the 4 main operations used in means advanced encryption cipher. So the mixed column operate in the linear transformation and operate such column to the state matrix AES and used to provide diffusion and confusion in the encryption process. So this is totally part of the security. So I think we will move ahead from this part. Yeah. So means what in fact we did in recent years, people working in construction of the course, security course are using the field theory, and nowadays the interest increase towards how we come from remove the field entity to general etc. rings. Okay, so recently my Bejo students transfer all these ideas from fields to ring. Means they using the total ring theory on construction of these cybertext. So I will just give us some reference because some work already have been done, but recently it is just a new idea in the context of the ring theory. Means security or MDS matrix over rings. So this is some idea how the cyber takes these are work, but I think we'll leave, not go into much detail, and then we will move on. This is construction from Galva ring. See how much is important. So the whole construction depends. Do you think how the most important component to us is the irreducible polynomial? Because with the help of irreducible polynomial, we construct a finite ring, means Galva ring. See, this is irreducible polynomial of order of degree 8. And with the help of this polynomial, we construct a Galva ring, and the entities of this matrix, this MDS matrix, will be taken from this thing. Okay. So this is just one result. Just I got the recent work in 2009. Try to shift from finite ring to finite field to finite ring. That was in the year 2019. So let I be a finite field of characteristic 2, I am greater than 3, be an odd integer. There are no invertible sequence matrices of size m which increase in the field of order q. So after that, people will work in totally the ring theory parts. So this theorem explains the constitution of IMDS matrix over finite ring. Okay, so let me be epimorphism from Galba, the Galba group to, and then we construct M by M matrix from this with the help of the units of that ring. Okay, is IMDS. So look at this M is IMDS if and only if M is generated by mu u and is the element of this u of that form. So this is very recent work, these two papers, and then we classify just residual class ring in RAS system. This is what the oldest system in the cryptography. So now it slowly will be moving towards the new system. So the Martin and Hale and Whitefield published their landmark public key paper in 1976, and then reverse RDS. This is called RSA system. RSA system means Revest and Samir and this Adliman. RSA system, the full name means the name coined with the name with these authors. Okay, the second one. So until now, the RSA system is most widely used system encryption ecosystem. Although the elliptical recently introduced in the cryptography for 10 years back, but it's now more popularly known as ECC. Then this is the some way to construct the public key part. So I think this, if I just definition, if we use the same as tool of mathematics, congruence relation, and define over there, then we construct these key with the help of congruence relation and the elements of the ring, that is Zn. Okay, like we can move this one, and then so this is what the RSA key generation, and how we generate the key. So there are so many components of this whole mathematical software, and we use this type of tools to construct these I think okay. Then we are come towards the last part, that is application of residual class ring in image processing. So as far as the image processing is concerned, we all know the image processing is the way to modify, to enlarge, reduce in size, okay, is a part of image processing. It is interesting to those who are working in the computer science, because they can modify the images very shortly in a specific way. So this is very interesting and recently developed area in the area of information science. So in digital image processing and computer vision, the image segmentation is the process of pertaining the digital image into the multiple images. Okay, and the logic is when you have you break into multiple images, and that again form a set. Okay, as mathematician, as an algebraist, our interest is to collect all these images and see what the set is look like, how it is work. Okay, so when they study going on. So the goal of segmentation is to simplify and or change the representation of image into the something to more meaningful. I mean, to analyze, like you don't have the exact picture of somebody and you want to know about more detail, then how you can use the information science to see the exact detail of that person. That is what we study in image processing. So there are several, the criteria and how to do in like pure information science view, and then the algebraic point of view. So our objective is to how we handle the whole process of the segmentation as an algebraist. So, nowadays is people are very interested to know the three-dimensional picture, like that, to see the movie, like that. So how to make it good-looking things, okay? So where these all methodologies are going to be used. So image via ring theories we are talking. So it is reasonable to assume the two images are similar when their subtraction approach to be zero. And now I'm talking mathematically. What is the meaning? So it is reasonable to assume that two images are similar when their subtraction approach to zero. Means then we say two images. However, the major drawback of this approach is that the negative values often arises. So leading some more research to truncate them to zero, but unfortunately this truncation does not effectively capture the true dissimilarity between the images and can result in loss of crucial information. Therefore, the alternative method needs to be explored to accurately represent differences between the two images. For this reason, it is necessary to define the structure of these images and take the operations and study as mathematical. So give the exact picture. What is that? So in that context, our point of view, how we use our ring structures to construct or to study the behavior of these images, as I said. So that means we collect images and we define the operation on the images and we study. So look at the main result that we give the information. So we have a matrix over Zn. The matrix considered over Zn, the set G K by M over Zn, the ring of integer modulo n, and where addition, multiplication are respectively defined to the pixel by pixel addition. I'm talking the pixel by pixel addition, and you take the images, okay? And multiplication in has the ring structure. So that means if we define addition as a pixel by pixel and multiplication, then it satisfies all the behavior of the rings. And now it becomes interesting for the ring theorist to see the.
This is point-wise multiplication.
Yeah. Pixel by pixel means that point by point. So that is the make rings more interesting, and look at the following observation are important in order to understand the main feature of the ring, that is G cross K M Gn. Okay, so the only point is we define pixel by pixel addition and then we study all this. So then we need additive identity, multiplicative and all these things. Then they all available inside. Okay, so neutral element for the sum is the image with all pixel have zero value and it is denoted by capital U in that study. Similarly, note the image which all pixel value are equal to 1 or say the symbol, give a symbol L, okay, is the neutral element with respect to the multiplication, and observe that multiplication between two images defined element by element, okay. So then this is beautifully look at the how the equivalence class And all these things will be help us to concentrate this one. Okay. So working with the image with the coefficient in Zn, right? One has better way to analyze the image, and the cyclic effect open a new way, largely reflect the resemblance of a graph level of a pixel with regarding to the neighbors. And then we define, you see, we have two images, addition A, B with this, and then R strongly, which may not in that way, and then the whole image processing part in context of the ring theory based on the idea of a collection of these images and the operation as equivalence classes. Okay, so that why it becomes more intensive for analysis, guys. So look at these images. Okay, there are different images. So consider these are images and how we can study their behavior. So this is one of the examples we will take. And this is very common example. If you're talking image processing, you put on Google, you can find these examples very much. Mainly this is very common examples. You can, when you write down on Google image processing, you can find very beautiful pictures. They look like very similar. So I collect these and how the ring subtraction, the additions it look like, but you need to some computational process to look by your eyes. Okay. Then this lot of I delete this. And so come on the last and this final part of my talk. So this is what we did in this area. Okay. So very specific. I not give to any other results. I just give my result. And if somebody is interested, just put my name on my homepage. You can find out all these paper I uploaded over there. Even in Math Science and Ali Shakir. And then you can find out. So the first, all these papers, we look carefully, they are in 2002 or 2023. Means we are working on coding theory. Recently, we started work from last 2 or 3 years. So the first paper is function of the quantum codes. Quantum codes, you know, the very important in the quantum computing. Very important and very interesting area. So on quantum information science, we have a big project in collaboration of the King Abdul University, Jeddah, on this topic. Means we're running such project from last 5 years. It's a very big project, more than, I think, 14 people working in the same area, specifically algebra, like Patrick Soul and S.K. Jain and Graph. Means there's a big group in this direction. And the second one code consisting of quantum code and LCD code from cyclic code. Okay. And so our first 3 papers, they are based on quantum information science. And the construction of quantum codes by a ring theory, finite ring based. And fourth one is, this is on constant cyclic code. This is also in similar means if you look on the ring, a specific type of the ring means make finite. So all these things in the sense of the finite ring. And the last one is on cryptography part. And just recently we find out very beautiful information how we replace the fields, finite fields by finite rings in encryption system, RSA system, CCS system. So the last paper is the role of ambiguous matrix in cryptography or in information science. So non-existence of some circulant involuntary orthogonal matrix over finite ring. So this is means the very recent paper, and where we are thinking the application of ring theory in cryptography. However, the image processing, we will not have any recent information, but the paper we have coded when we started on the image processing is already published. So this is also very interesting to see how the other like Galva rings behave in other type of image processing, but it is still need something to be more apart from this. So this is what we are talking about today's talk about the role of abstract algebra in information science. So we are going to be in, and here these are some books. You can look over these books. And thank you very much for all your patience. Slot 10-5.
Thank you very much, Prof. Shakir Ali, for the very nice talk. Now, time to ask a question. Please, anyone have a question? You can share in the forum.
Professor Shakir, something that's it's only a very basic question. When you introduce the ring of residue, the ZN. So I try to introduce it using also relation, but the rest, when we have a group and then we have a subgroup, normal subgroup, then we will have a factor group. Okay? And also when we have a ring and we have a sub ideal, then we will have a quotient ring. And then we introduce the ring of the residue using this ideal of NZ and the ideal NZ. So it seems it will be more easier, but because then the group the ring factor will be get it in a very easy way. What's your comment?
No, this is good question, basic, because I not discuss all these issues because we just the basic background of algebra. Yes, this type work already been a lot of interesting things already done where we're taking the ideals, okay, because the base most
because then the ZN automatically is a ring.
This when you have the irreducible polynomial, the ideal generated irreducible polynomial itself is the maximum ideal. It has, then we have the beautiful construction. Yes, it's going on. Research is going on.
Okay.
Yeah.
So because we, I try in two ways.
Yeah.
And then for the student who have background with the ring, it will be easier with this way.
Yeah. Right.
Okay. And for the application, come to the application is we need some process, and then it's, but the student sometimes would like to know the application soon. But to get the application, to understanding the application, need a lot of
process.
How to handle such question? I said to the student, we need some process, so not directly you will get application after you learn the ring.
Yeah.
Well, how to convince this?
The best answer to such questions means in my knowledge is when you have such, if you shouldn't asking such questions, if you have your Malik means in your mind some pinpoint, means you have now I think if somebody asking what is use of abstract in information science.
Yeah.
So to answer such questions, we should have some critical means a surrounding area and choose one of them and to give them. Okay, see this like right now, if we're talking about application of abstract algebra, then the best example, everyone has mobile. And in mobile, you are using net banking. And of course, in net banking, there are a lot of things inside. But if you do like that, yes, if you have mobile and you know you're doing such a type of things in algebra, and this is the best example of the application of algebra in nowadays mobile. So students quickly understand, yes, this application of algebra in mobile, before they not know. But for moving the whole process, of course, they need something inside. But for the quick answer, you need such type of examples. Give the quick look for the students or to audience. Yes.
Okay. Thank you. So we face the same problem. Explaining to the student.
Yeah. Thank you.
Yeah.
Because when I was reading the project, that's how to create in taste in algebra. I was in Saudi Arabia, so somebody asked me. So somebody asked me this. Then I will come back after one next meeting. Then we will decide. And next day I go in the class, but in my mind the same question. I go in class and ask question, students, do you have some application of mathematics like that? Start from this point. Then students slowly, because they are from Arabic background, so they are keep quiet, never try to speak. When I ask this question, do you have no application of mathematics in real life related to you? Then some faces of some students look like smiles. Means they are more interested to know the applications. Then I suddenly ask, how many people have mobile? This everyone raise their hand. Yes, Professor, I have mobile. Do you know the role of mathematics in mobile? Now, then I see the faces of all students, those who are sleeping in the large side. Now their eyes very open. Oh, doctor. Yes, and the first application of mathematics, in particular algebra, in the mobile, you are using net banking. But yes, doctor, yes, this is what is algebra. Then after that, the atmosphere was very good because they are always coming to smile, asking that give me some more application. So this means if you motivate to the students and connect the mathematics to the real world problems, then really it becomes very interesting. Okay, I mean, just say, for example, this is not mathematics, information science. I told you mathematics is very, very important. Mathematics is using, the sports. Okay, mathematics and sports. This is a very interesting area. If somebody is where the mathematics play important role. Mathematics and medical science, everybody know? Okay, like for example, we have medical students. If you not medical students, if you're asking, do you know the disease that is called vectorial? How is growth and what the mathematical model? If you give the example on the board, this is the mathematical model and this is the disease. Definitely, they never will sleep in our class and they will enjoy the whole class what we're talking. So I think, as far as me concerned, if we teach mathematics, we just let the audience, students, first thing, why study this paper. For example, now I'm teaching abstract algebra and I come in class on the first day. So I should ask the student, do you know why you study abstract algebra? What is the role of abstract algebra in real life? And how we connect this abstract algebra to the society. If we give answer of these three questions to the students, then I hope they never sleep in our class.
Yeah. Okay. Thank you very much. Mungkin yang ada di online.
Yeah, maybe. Yeah. Thank you. The online participants.
Yeah, maybe online somebody check on.
Some questions for the online participants. Okay. I have a question about image processing. What is the main reference or maybe
I think for image processing, the main reference I already coded, and when we start I already have some references. Yeah, this one and then. Yeah. Look on the first slide where we give the motivation. Yeah, this one, 3. The application of ring theory in the segmentation of digital images. So this is it. There are some more, but I just pick up only the ring 30 version. Yeah.
Yes. Okay. Next question, please. Already. Some participants asked me, is possible to get your slide after this?
Okay.
Oh yeah. There's a question from chat from Mr. Zakirianto. Hello, Pak Zaki. How about the Mekaris system over this kind of framework? Atau mau punyatan sendiri, Pak Zaki? Do you want to share it direct?
Oh yeah. Thank you. I just want to ask about the application of this kind of code, especially code of residue clustering to the Mekalis crypto system. We know that today the Mekalis crypto system is defined over the Golang code. That is.
Sorry, can you repeat your question?
The code, yeah.
Which crypto system you are talking?
Mekalis crypto system. Is it possible to do like this in Mekalis crypto system? To use residue class?
Because the residue class using is not only the Alice system, it is applicable in almost all crypto systems because it is a recent study and it has a lot of some literature to do. So it is applicable in I think in other crypto system as well.
Okay.
So yeah, it's possible, but then the answer again. Okay, the next question. No? Okay, thank you very much for this talk today, Dr. Shakir Ali, for overview about application of abstract algebra, especially ring theory, and some kind of vector systems and coding theory and also image processing. I think we have a new knowledge. We all learn something today, and we hope we can continue or we can improve our knowledge with this seminar, with this talk. And as for your information, Professor Shakir Ali will stay in UGM until tomorrow. Yeah.
Yes.
Anybody who wants to discuss, he welcome you.
Most welcome. Most welcome.
So come here to the police office, and thank you very much for everybody here, for organizer and also for participants, and for Professor Ali Shakir Ali. Thank you very much. We will meet again tomorrow, inshallah. In Kontrakan algebra.
Oh, okay. Thank you very much. Thank you.
Okay, see you again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.